Here's a short but quick video on how to do integration by substitution. Integration by substitution is essentially a way of integrating by changing the dx, by substituting into a different dx, by integrating it with essentially a different passport. They don't really teach you this anymore because they don't actually teach you the foundations of integration and differentiation. But dx is essentially a bit like a passport, or a visa even. It tells you where you can go. And when it says dx, you can integrate in the x universe. Whereas if it was du, you can't integrate x terms you can't integrate x terms in the u universe normally. A bit like if you're going to China and your visa says you can't go to Hong Kong as part of them, it's only mainland China, then that's the same. I don't know that much about visas. What I do know is how this works. Basically, you need to find a unit to substitute in for tan, and then therefore use it to change the dx, while also making sure you have no x terms in there. It seems a bit complex, and to be fair, looking that far ahead normally is, but there are normally a few tricks which you can learn from here. One, if there's a tan x, then there will always be a sec squared x. And in general, you should pick the tan x. The reason why you pick the tan x is the differential of tan x is sec squared. Du by dx would be sec squared. So, then your dx would be du over sec squared x. I know, it's surprising. We'll rearrange a differential, I know. This is actually the first time that you guys do this normally. But it is possible. Right. So now we can rewrite that equation. And we can rewrite it just replacing the dx with the du with the sec squared. Now, as you can see, my sec squareds disappear quite easily. And now I have a term which I can substitute in its own universe. So, the whole point of this wasn't changing it to du. The whole point of this was making it simpler. And that is essentially what differentiation by substitution is. It's a skill of manipulating what you have so it's a simple equation. Naturally, that integrates to u to the power 6 over 6 plus c. Make sure you have the plus c in there. Although you never leave it in that form, otherwise you'll lose a mark. You have to convert it back unless you have unless this is. I'm doing indefinite integration. If you're doing definite integration, then you have to put your numbers in. And you can put them in at the u stage, but if you do that, then you have to convert them to the u's, which I'll show you in a minute. Right, and then that will just simply be tan to the power 6 over 6 plus c. And that's it. Fair enough? Okay, here's another one. Generally, the ones that they give you here are quite easy, but they still get high marks. And for some boards, they're very predictable. Like that question there. It'll be literally, the only thing that will change is the power and the tan. Another really predictable one is the sine to the power cos x multiplied. And the other one is cos to the power sine to the x, and this is the other one which is also very predictable. And it is simply a form of bracket kind of thing. again, I look at what I can use to make this simpler, which normally means getting rid of all the terms. So I know that the differential of x squared turns into, oh sorry. The other thing, if you want to get rid of a term, it's very hard to get rid of a term with the power of 6. Or squared or anything. It's a lot easier to get rid of that. So when you're looking for stuff to get rid of, bear that in mind. So yeah, if I make u equal to my x squared plus 1, my du by dx equals 2x, and therefore dx would equal du over 2x. I rewrite that, and that would go into x upon x squared plus 1 to the power of 6 on du over x by 2x. My x is cancelled, but the 2 stays, and that becomes u to the power of 6 over 2 du, which then simply turns into u to the power of 7 over 14 plus c. Now I am going to tell you what happened. So I'm going to put in the numbers 1, 0 as one integrating between. Right? So naturally you don't leave this by itself. That also, if you are integrating in a range, you do not need a c because the c's cancel. So we'll put 1 and 0 just to be simple. And then that would turn into just 1 over 14. Whoops. And that's a mistake that everyone will make. They will say it'll turn to 1 over 14. But what am I doing? I'm doing x terms. And why am I doing x terms? That's a dx, but this isn't. And these aren't x's. What you need to do is you need to turn them into u terms and use that ratio, well, that equation. So you literally do 1 plus 1, which gives you 2. So you now have your terms, and your lower term as well, so that's your upper term. Your other one is 0 plus 1, which gives you 1. So it's shifted up, it's all shifted up 1. Now, does this turn out the same? What is that? That would be 128, if my math is correct. 128 over 14 minus 1 over 14 gives me 127 over 14. 127 over 14, just making sure that if that is divisible by 14, it's not. What that is that would be 9 and 1 over 14. If you would put into compound fraction, but top-heavy fractions always useful. However, you have to leave everything in 3 significant figures.